All right, shall we begin? So let's continue from where we left off on Monday, where we learned about how to build Boolean expressions. These are expressions that result in either true or false values, and we use these to create programs. In particular, we want to create a program that verifies user input password. And we start off with a simple assumption that a password is valid if it has length at least 8. So we create a Boolean expressions so that this will return true if and only if the length of the password is at least 8. Okay. Now, and then we're going to extend it to where it's not just that the length of the password to be at least 8, it has to contain at least one special characters of the following. One of these. So this will require us to create a second Boolean expressions such that it will return true if at least one of the following is inside the user's input, right? So we create these Boolean expressions for that purpose, where as long as one of these symbol here, $, hash sign, and exclamation mark is in the password, it will return true. And we join this with the previous condition where the length of the password is greater or equals to 8. So in this case, we have a Boolean expressions that involve and or. All right. So we have learned that both Boolean condition has to be true for this is valid to be true. Okay, because we're using an operation here. Now for or operator, so this is where we have 3 Boolean expressions joined by 2 operators. As long as one of them is true, it will be true. Okay, and here we're using the in operator to check whether this string with $sign is actually inside the password. Okay, so this code is all right, but as a programmer, you always want to separate conditions. Okay, so that you know exactly which conditions that will cause you error. For example, so we have one condition to express that it is greater equals the length of the password is greater equals to 8. So has length 8. Okay, so it will be length. So we separate out these Boolean expressions into a variable. Okay, so now has length 8 is a variable that is assigned to true or false based on the value of this, whether the length of the password is greater equals to 8. All right, and then I have a second condition or second variable that is stored into a second condition that is stored into a variable that will be called has special character, for example, and I separate this out to be initialized to for the variable has special. Okay, so I have 2 variables. These 2 variables will be true or false based on the Boolean expressions assigned to them individually. And then my is valid is equals to has length 8, okay, and has special. So is valid will be true if has length 8 is true and has special is true. Okay, so this has the advantage of that. If, for example, in the future, you say we will allow more special characters. So instead of $sign, now I have maybe allow this special sign here. Okay, so then I'm going to check, I'm going to change here only in has special. Okay, so I will have or with this additional sign that I allowed in password. Okay, so you only change has special here, you don't change other things. So this is the advantage that you separate the 2 conditions. Okay, so we always create such a variables for, and also it's easy for you to debug. You know that if there is an error, you know that has length is true because we already do problem 1. We know that this is going to be all right. So if there's any error regarding this, it has to be because of the way you build has special. We'll look at the second examples that will illustrate this point. Okay, so problem 3, I create a third condition. It must contain a digit. So what are the possible digits? 0 all the way to 9. Okay, there are 10 digits here. So we want to check if 0 is in the password, 1 is in password, or 2 if it's in password, and so on. Okay, so again, this is an extension from before. So we're going to copy and paste here. Okay, so I have First condition has length 8, which is from before. And second condition has special character, the same thing as before. We need to add one more condition, which is contain a digit. So has digit, okay? And then this is the Boolean expressions that I want to build so that at least one of these digits here is inside password. And of course, its valid will contain all these conditions, has digit here. So I will have its valid is equal to has length 8 and has special and has digit. So what is has digit? This is a Boolean expression that I want to build. So it's the same thing as has special. Okay, we want to check whether some element is in password, and these elements are the digits. Either 0 is in password, either 1 is in password, 2 is in password, and so on. Okay, so I already write it down previously. And I'm gonna copy and paste here. Suppose this is what I built here. I check whether 0 is in password, or 1 is in password, or 2 is in password, or 3 is in password. Now, let's run this, and I want you to discover what's wrong with this code here. Okay, so suppose I enter a password with at least 8 characters. I start off, for example, with 8, A, B, C, D, E, F, G. So this has at least length 8. It also has the special character that we need. It also actually has a digit. So let's run it. And then you get an error called type error. All right, so this is the time that you pause and think, what does it mean that type error here is say, in string requires string as left operand, not int. So what does it mean? So we have something like this 0 here. Is 0 a string or a number or an int? This is an integer. So it's saying that it cannot be an integer. It has to be a string. How do I make this to string? Exactly. So it will be quotation mark. Okay, so this is the very typical mistake that students often make. When I ask you to check whether it has digit, usually students just check whether a number is in that password. So you have to make everything into quotation mark. Okay, continue and so on and so forth. And so as you can see, we're creating a lot of expression here. Enjoy them using the OR operator. Just gonna illustrate one more point here. Suppose I have this. Okay, again, I change everything to string now. And I'm gonna check, for example, 6, A, B, C, D, E, F, G, this. Okay, let's run it. It says the password enter is valid, but it's whether the password enter is valid is false. So it says that the password is invalid because it's false. Now, look at this. Do we have a digit? We have length at least 8 and a dollar sign. So what could be an issue here? So this is where you start to think, could the B issue be has length 8? This is no issue because we started off with problem 1. We are ensured that problem 1 is right. This expression is all right. And then has special, which already started in problem 2. Again, we're sure that it doesn't have any issue with that. So we know that if there's an issue with this code, it has to be has digit. So this is where you start to look for. There is no error, but it gives us the wrong result. These are supposed to be valid. It has digit, but it says that it's false. So you investigate only in has digits. This is the power of starting small. You start with a simple assumption and build it up so that you know exactly what to look for when there is no error, but the output is not as intended. So you know has digit is what you need to figure out what's wrong. So you look for 6 here. If you look here carefully, there's actually no 6. So I make a mistake, or just now I intentionally delete this just to show you the point is that where you want to look for when there is no error message shown, but the output is not what you intended. You realize that you missed one point. 6 is not in your Boolean expressions that you want to write for this code here. Okay, so now you add it, and you're gonna create the same password again. Okay, and now it say, did I make a mistake? Bool object is not callable. Good. Perfect. Good job. Let's do it. There you go. And now it's true. Okay. So one other thing that I want to point out, when you create a lot of Boolean expressions joined by or, there are 10 Boolean expressions here, it's easy to make mistake. And of course, it's a lot of manual work. So we want to bypass these manual works. First of all, the more things that you type, the chances that you make mistake is high as well. Just like what I did, that I missed one of them. And I don't want to be having to check every single such of these 10 expressions here. So we always look for, as a programmer, you always look for, is there an automated way to do it? Okay, so one thing that we can do is to use for loop, which we will learn later. And then another thing that we can also do is to use the set data structure. So this is something that I will talk about at the end of the class. So now I just want to point out, this is correct, but we always look for a way so that we can mitigate the issue of having manually create these 10 expressions. All right. Now here's another example where you have all the previous conditions. All right. Plus one more condition, it must contain an alphabet. All right. So the same thing, I'm going to copy and paste everything from above. And we only need to make sure that we create another variable for has alphabet. Now, for questions like this, is also, you have to think, what does it mean by has alphabet? Okay, so has alphabet. So what are the possible alphabets? Okay, so what are the possible alphabets? A, B, C, D, E, all the way to Z. Are these all? How about capital? So it didn't give me any indication whether it has to be lowercase or uppercase. So it turns out we can actually have alphabet as well, capital cases as well. So we're going to have a total of 52 characters, alphabets that we want to test. Okay, so earlier on, using 0 all the way to 9 is 10 Boolean expression joined by or. Now I have 52 alphabets. I want to check letter A, is it in password? Letter B, is it in password? Capital A, is it in password? And so on. We will have to create 52 expressions joined by all operators. And this is where it comes to the extreme point that you really don't want to write 52 expressions. Okay, so this is something that we were going to deal with and so on. But for now, it's for food of thought. What would you do differently? If you don't want to write 52 Boolean conditions to check every single alphabet here is inside the password, what you can do. Okay, so we're going to bypass this all the way to the end of the lecture where we talk about this. I just want to point out that you can do this individually with Boolean expression where the letter A is in password or capital A is in password and so on. But we're going to bypass this. We're going to look at another version first where it's easy to mitigate the issue when it does not contain punctuation or special character. Okay, so you are asked to create a program that has length password at least 8. It must contain a digit. It contains at least one capital alphabet, at least one small case alphabet. It does not contain punctuation or special character. So here, it's a special case that is different from all the previous one, where instead of it has to contain a special character, now it does not contain special character. Now, what makes this different from the previous others is that for this problem, because of this condition here, I can start using the built-in method. So whenever you create a problem, when you want to solve a problem, the first thing that you want to do is that, has there already been a built-in method available for you? So if you want to look for all the built-in methods, you use dir, built-in method over the string. Okay, now you have all these here. We have looked at some of these before. For example, we have looked at upper to make everything into upper cases, to make everything into lower cases, and so on. Now let's look at some of these here. We have is alpha num, is alpha, is digit, is lower, is space, and so on, is upper, and so on and so forth. Okay, so let's look at some of these that we might use. So we use help. to figure out what of these methods here. So we have string dot is alpha. Okay, it's returned true if the string is alphabetic string. Okay, if it contains only alphabet, then this string dot is alpha will return true. All right. Another thing, let's explore more. So would it help us in our problems? We're gonna figure it out. String dot is alpha num. Okay. It's L num. Okay. It's returned true if the string is an alpha numeric string, which means it contains alphabet or numerics. Okay. So for example, this string here, if I do is L num, it's gonna give me true because it contains alphabet or numerics. If it just contains alphabet, it's also true. If it just contains numeric, it's also true. Okay, if it just contains numerics, it's also true. So as long as strings contains only alphabets or numerics, it's true. But if it contains any other special characters, it's false. Okay, so this is closer to what we want because we know that we don't want any punctuations or special character. We want it to be alphanumeric only, doesn't contain any punctuation and special character. So we very close to what we want here. Okay. However, it's still not exactly what we want. Okay. So we know, so let's write down what we know first. Okay. What we know is that there is a built-in method or is alpha num, is L num, okay, that returns true if the string contains no special character. Okay, this is good. It take care of this condition here. So we know that it's valid has to be is alphanumeric. Okay, so we know that we can create an expression called it's valid. It has to be password dot is L num. It has to be true. It has to be alphanumeric only. It doesn't contain character. Okay, any special character. Okay. Now we also need to take care of the previous cases. Okay. So the previous cases, length of the password must be greater equals to 8. And here, I can create a special variable if I want to. So no special character. So I can create, say, has no special is equals to this. Okay. So I will have has no special here. Okay. And there are more. For example, I need to take care of these cases here. It must contain a digit. Okay, this is alpha num is not enough. It just say that as long as it doesn't contain special character, I will return true. Doesn't mean that it must contain a digit. Okay, so for example, ABC contains no special character. It doesn't, however, it doesn't contain digit and we will still return true. So we need a way to say that, hey, it also must contain a digit. So how do we do this? Can you use all the things that you have learned? So for example, let's try string dot is digit. Okay, it say that it will return true if the string is a digit string. Okay, so it seems like there is no such thing called must contains digit, must contains alphabet, must contain capital alphabets or lowercase alphabet. Is that means that okay, we have to go back to this version where we create multiple Boolean expressions for digits, multiple Boolean expressions for alphabets. So now is the time for you to think outside the box. What can we do? Can we use all these methods that seemingly is different from what we really need? Can we use that? So if you think a little bit, okay, so if a password must contain a digit and must contain an alphabet, means what? Means it must not be just a digit. It must not be just contains digits. It must not be just contain digits. Okay. And it must not be just contain alphabets. Okay, so notice here the word not here. We are using negation now. Okay, it means that, so it means password is such that, it means that it should be not password dot is digit. It cannot be just digit, and not password dot is alpha. No. Okay, it's not just sorry, alpha. Okay, so it must not be just digit, and it must not be just alpha. So this is what we're going to use. So has digit and alpha is equals to password dot is not just is digit, not password is digit, and not password dot is alpha. No, is alpha. Okay, so we have two conditions here. It must not just contain digit, and it must not just contain alpha. Okay, so it will contain at least one digit and at least one alpha, not just digit itself, not just alpha itself. Okay, hope I type it correctly here. Okay, good. That's it all? Did we cover all the cases? So let's just try it. Okay, so say I need a length 8 alphabet, so I would something like this, and what else? No special character, it has contained digit and so on. Is okay, and has digit alpha. Okay, so I have some alphabets, I have no special characters, and I have some digit here. And you say it's true. Let's try a different one. So I have some alphabets without digit, and it's a blank end. Length 8 is false. Okay, now let's try a different one where I have some digits and an alphabet, but I also have special characters. It gives me false as well. Good. It covers everything, but not quite, because it says that it must contain at least one capital alphabet and one small case alphabet, but we only cover small case. Okay, so it's not quite what we want. So we need to improve it further. Okay, so we need to deal with the case of it must contain one capital alphabet, it must contain one small case alphabet. Now again, okay, so the above code does not handle the case where we must have at least one capital case and one small case. Now again, this is where you start to look for all the possible methods that is available to you. And you have something called is upper, and of course is upper. Now you just do a quick help. Okay, it will return true. It say that is lower is a method that will return true if the string is a lower case. Now the same thing, we have string dot is upper. Okay, it will return true if the string is an uppercase. Now, based on what you have learned earlier, if it has to have digit and alpha, means that it cannot be just digit and cannot be just alpha. Can you also form this Boolean expression for which it must have at least one of the one capital case and one small case? Okay, so the conditions, let's see. So the conditions to have at least one capital case and one small case is equivalent to checking what? Okay, so let's use what you have learned before. So the condition that you need at least one digit and one alphabet is equivalent to that the password must not be just digits and must not be just alphabets. Okay, so this is the same thing here. You say you have at least one digit and have this one alphabet means that it must not be just digit, must not be just alphabet. Now, I have a second condition which is similar. You say that it must have at least one capital case and one small case. What is it equivalent to? That the password, can it be just lowercase? If it must contain at least one capital case, it cannot be just lowercase. That the password must not be just lowercase and must not be just capital case. Okay, so you have already two methods for you to check whether it's lower and it's upper. So the same thing, I'm going to use a negation on it's lower and it's upper for this purpose. Okay, so we're going to do one more step here. Has capital and lowercase, okay, which is again not password dot is lower and not password dot is upper. Right, and this should cover everything. So we're gonna give it a try. So if it's less than 8, it's false. So if the length is more than 8, all right, and it contains digit, it's true. And what else? Sorry, actually, let's try this. It says it's true, but this should be false. It only contains small case letter. Can you tell me what's wrong with this code? It's actually a very subtle error. So what is your is valid here? The length is at least 8. It has no special character. It has digit and alpha, and has capital and lowercase. Okay. So we actually built the Boolean expression, but we forgot to put it into n here. So if I do the same thing as before, and I get false now, because it doesn't have capital case. Now let's do something like if I have all the capital case with some digit, it gives me false as well, because it did not contain small case. So let's try a different one, some capital case and some small case, some digit, and now I got it true. All right. And again, you should try it out, for example, if you have special characters. Everything is right except that it has special characters. It also gives me false because it's not supposed to have special character, has no special. All right. So here is a illustrate to you that how you can use the methods that is available to you to help you solve the problems. Now, for this case, when you say that you want certain case to exist, certain conditions to appear, you need to think about it, how to use the built-in method that is available to you. There is no built-in method called has digit. There is no built-in method called has capital alphabet. There's no built-in method called has small case alphabet. But we can think outside of the box how to combine these built-in methods that we have so that it satisfies these conditions. We cleverly create an equivalent version of the conditions, where if it must contain at least one digit and one alphabet, it's the same as saying that the password must not contain just digit as must not contain just alphabet. And hence, we can use the built-in method with a negation to help us to create this Boolean expression. The same thing, if it must contain one capital case and one small case, we create an equivalent version of negating the Boolean expressions by saying that it must not be just lowercase and it must not be just capital case. And the same thing, I say that it must not be not password dot is lower and it not password dot is upper. Okay, so this is what the programmer does, is that when you have a built-in method, you always think how to use this built-in method, adjust it, create an equivalent version of conditions that you want using this built-in method to help you solve the problems. All right, so these problems for this problem, it has a built-in method that we can use to solve this, primarily because I take out the condition that it must contain some special character. For problem 5, it does not contain special character. Now for problem 3 and for problem 4, however, the fact that I allow special characters makes the following program doesn't work anymore. Okay, so this is something for you to think. Can I still use built-in method for problem 4 and problem 5? Problem 3 and problem 4, where it requires a lot of Boolean expressions to be built. Now, there's no easy way to do it. So I'm going to look into it. I'm going to write it down here. So this is extra information for now. We're going to actually look at it after we learn about for loop. Okay. So for the following problems. Okay. For problem 3 and for problem 4, just look at problem 3 for now. Okay, so the same thing applies to problem 4. Okay, so say for problem 3, so we just look at problem 3. Okay, so you have these conditions here where you can create where you require a special characters. So there is no easy way to bypass this using the built-in method that we want, and which require us to create 10 Boolean expressions joined by OR for it to contain the digit. Now, so I'm going to write the code for the code above for problem 3 requires manual creation of 10 expressions joined by OR. Okay. How do we automate this? Okay, so one approach. Okay, so option 1 is to use for loop. Okay, so we will look at this, I think, in lecture 5. Okay, in later part of the course. Okay, and so this actually, when I create all these expressions here, I did not create manually. I actually run the for loop and concatenate the strings, because as a programmer, you always think, how do you not do it manually? Okay, so you use for loop. So we're going to look at this at later part of the course. And option 2, so if you remember, okay, if you remember earlier on, we talked about set. Okay, we have briefly talked about the new data structure called set. So this will not be tested. Anything under remark is just extra information. All right, so just to let you know that there are some other ways to do it, and we just to give you information on some things that you can think about. So when we talk about set, these are an order collection of things. Okay, so we say that if so the password, so a password, a string, a password contains digit if the set of characters in password intersects has at least one intersection with the set of digits. Okay, so we're looking at intersections. So probably you have learned in high school, if we have two sets, if in the intersect means there are some elements that appears in both sets. Okay, so let's look, for example, let's look at password equals to say R something with a digit 3. Okay, so and then I will have say I'm gonna convert into set. So so password is of type string. I'm gonna convert it to set. I'm gonna looking at everything as a set now. So I'm gonna use a type conversion set, and then whatever that I want to convert to. Okay, so now let's look at my password set. This will contain the set of all the characters in password. As you can see here, it contains 4 elements here, because for set, any duplicate is going to count, is only store once. Okay, so if you remember, set is where any duplicates is only stored once. All right, and then let's look at digits. So digits contain 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and again, I'm gonna make it into set using typecasting. All right, and I'm going to check what is digit set now. It contains all the string or characters of representing digits. Okay, so now I'm going to do, so I have 2 set. All right, I'm going to check whether there is an intersection. That means, is there an element that appears in both sets? If there's an element that appears in password set and also in digit set, that means there is a digit appear in password. Okay, so a password will contain digits if the set of characters in password has at least one intersection with the set of digits. So how do we do intersections? So in Python, okay, intersections of 2 sets is use the vertical operator. Okay, so let's see, digit set intersect with password set. Okay, actually, oh, it's actually, this is union. Okay, hold on a second. Let's check set. Okay, we're going to use this intersection here. Okay, so we're going to do this dot intersection password set. Okay, it say that using dot intersections. Okay, so you say that if I intersect digit set with password set, what I get is 3, because 3 appears, is the only characters that appear both in digit set and in password set. Okay, so if I create a different one, say 1, 3, my password set will contain 1, 3 DKR. Okay, now if I do intersections, it contains 1 and 3. So 1 and 3 are the only elements that appear in both digit sets as well as password set. So now we wanted to show that the intersection is not empty. So give you a different example. Say if my password contains no digit at all. Okay, so my password set will be DKR. If I do intersection now, it will have set empty. So we wanted to know that, in other words, so we check whether password contains a digit by checking if the password, if the intersection of digits set and password set is non-empty. By checking if it's non-empty, it's the same as equivalent to check if the intersection is of length at least equal to 1. If it's empty, the length of the intersection will be 0. If it's not empty, okay, the length of the intersection will be at least 1. Okay, so we're gonna do that. So here's our final code. So we're gonna borrow the code from problem 3, which is here. Okay. Over here, problem 3 has digit. I'm gonna replace it with the one that we have just mentioned. All right. So first we create password set, which is a set where we convert the password to set, and we contain digit set, which is where we have here. I'm gonna copy here. Okay, and then we're going to do intersection, which is equals to digit sets dot intersection password set. All right, and has digit will be true if the length of the intersection is greater equals to 1. Okay, and that's all. So the difference is that we bypass having to write 10 expressions using OR by cleverly looking at the intersections of the set of characters in the password with the set of characters, with the set of digits, and look at their intersection. If there is at least one intersection, which means that there is at least one digit in the password. Okay, so how do we check whether there is at least one elements intersect both sets? We check whether the length is at least equals to 1. All right, so these are extra informations. And again, the idea is to show you that how do you think outside of the box? How do you think, if you don't have the built-in methods, how can you use whatever that you know to piece together to form a solution for this? And again, this is extra information. Later on, we're going to learn how to use for loop to do that. That will be tested. For this, it will not be tested. Okay. For now, please settle down to do your quiz. I'm going to start the quiz now.